Hello everyone. Today we're looking at Ethernaut Level 16, which is preservation. On this level, we have a contract that is using a library to store two different times for two different time zones. The constructor creates two instances of the library for each time to be stored. Our goal for this level is to claim ownership of the contract we are given. So we have two contracts, the library contract and the preservation contract. The library contract by itself is fairly simple. It just has a uint stored time and a public function to update the value of this variable where stored time equals underscore time. In the preservation contract, it takes in two addresses and it sets time zone 1 and time zone 2 library addresses to the constructor params. And it also sets owner equals message.sender in the constructor. And then we have two public functions, set first time and set second time, that take in a uint timestamp, and they both do a delegate call to the respective time zone libraries and call the set time function with the passed in timestamp. Now, immediately, there's a red flag over here that why are they using delegate call? Right? Never use delegate call unless you're 100% sure of what you want to do, and it only makes sense in very specific cases. Our goal for this level is to update the owner variable, but the only place the owner variable is being changed is in the constructor. So we need to do something else. And what we need to do, we'll have to trick delegate call. We'll have to exploit the fact that they're using delegate call. So what I'm going to do, I'm going to get a new instance of this contract, and then we'll head on over to Remix to see what's up. Once we have our contract instance, I'm going to simply head on over to Remix and I'll create a new file and call it preservation.sol, and I'm going to copy paste all that code in there. So we have this contract, library contract, fairly simple, and we're doing a delegate call to it. Now, if you've seen the previous levels of Ethernaut, you know that when we're doing delegate call, it's kind of like importing this code at runtime, importing this function call at runtime into this contract, and it behaves as if it's being executed directly over here. So it carries forward the storage context, it carries forward a bunch of variables, and it almost behaves as if it's being executed directly in here. So in this case, uint stored time in the contract is at the storage slot 0 for this contract. So when we're doing a delegate call, let's say from set first time, when we're doing a delegate call to it and we're updating the storage slot, since it's a delegate call, what it will actually end up updating is storage slot 0 in the preservation contract, which is time zone 1 library. So it will actually end up updating time zone 1 library, and time zone 2 library is slot 1 and owner is slot 2. So we need a way to update slot 2, and we know for a fact that this library contract and these delegate calls aren't designed properly. So even though they're attempting to update the time, it's actually updating the address of time zone 1 library. So here's what we can do. We can design an attack that works in two steps. Step number 1, we deploy an attack contract and we update time zone 1 library, the variable, to address of our attack contract. And we can do that by passing in a certain value for timestamp over here. And since it updates this address variable, we can change the address of this to whatever we want. In our case, we'd want to change it to our attack contract. Once that is done, we can call set first time again, such that our attack contract updates storage slot 2. How does this look like? So I'll create a new contract directly in this file just so everything's together. And what we're going to do is we're going to copy and paste the storage structure of our preservation contract up until the owner. That's the only thing we care about. Once we have this storage structure, we want to create a function like in the library. We want to create this set time function, but we don't actually care about the time variable. So we're just going to get rid of it. And instead of trying to update stored time, we're going to do owner equals message.sender. So our goal is to first set time zone 1 library equal to the address of our attack contract. And then the second time we call this function, it will be doing a delegate call to our attack contract which will then update storage slot 2, owner equals message.sender, which will also update owner in the context of the preservation contract. So with this code in place, let's head on over to the deployment tab, switch to injected provider, and deploy our attack contract. Confirm this. Once the attack contract is deployed, we now know the address of our attack contract. So I'm going to copy this address, and let's head on back over to Ethernaut. And for sanity, let's check what is the current time zone 1 library. What is the current address of this? So currently we have this address. And we have our attack contract address now, which is, I'm going to set it equal to a variable here. Now, since this is an address, attack.length, this is 42 characters. But timestamp expects a uint, and uints are 64 bytes. So to convert this, to treat this address as a uint number, we need to left pad it with a bunch of zeros, so it becomes 64 bytes and becomes like a uint number, but retains the exact same value. So to do that, we can just do const padded attack, and we'll do web3.utils.pad left, and we give it the attack contract address, and we tell it to pad it to 64 bytes. And now padded attack, we can see, is basically the exact same address as this one, just with a bunch of zeros towards the left. So this whole thing, so padded attack.length is now 66. And if you remove the 0x from the beginning, 64. With this in place, we can now call the setFirstTime function. So let's do await contract.setFirstTime and give it the value of the padded attack contract address. Confirm. And once the transaction is mined, let's take a look at timezone1 library again. So if I do await contract.timezone1 library, we'll see that this address is now our attack contract's address. Previously it was this, F88 and ending with A30, and now we have this, our attack contract address. So with this setup, if we call setFirstTime again, it will now delegate call into our attack contract, which should then change the owner. Right now, if we check contract.owner, it is set to whatever this address is. Now let's do await contract.setFirstTime. It doesn't matter what you call it with this time, because we ignore the time value being passed to us anyway. So I'm just going to call it with the same padded attack value again. Confirm. And once the transaction has been mined, let's check our owner again. So we'll do await contract.owner. And this is now my address. So we can now go ahead and submit instance, confirm this, and boom, there we go. So as we've seen in previous levels, delegate calls are risky, and they should only really be used when contract libraries do not maintain their own state, like they're stateless. And that's why we have the new library keyword in Solidity now, as it prevents them from storing and accessing state variables. But cases like this, where on the surface, if you didn't know how delegate call works, it would look okay to you. We have a variable, we're updating that variable. But the whole idea around the fact that it's actually updating the same storage slot in the contract, which is doing delegate call, allows us to exploit this function. That is all for this lesson, and I shall see you in the next one. It's going to be recovery.